This chapter is already short. Okay, so I didn't find anything very important. Who joined? Dhruva. Okay, so let's good morning, good evening, all of you. So let's start the class. So today we are going to study about coefficient of viscosity. We already learned what is viscosity. Yes or no? It's basically a viscous drag. It is due to the short range molecular cohesive forces. One molecule, similar molecule, pulls the other molecule with a force, dragging. Basically, I told you example that when a person is going, another person is pulling. So that's called cohesive force. One molecule acts a viscous drag, some force, some drag, because that's how the viscosity. We also studied what is velocity gradient. What is the velocity gradient? The rate of change of velocity with respect to the distance. Okay, measured from a stationary layer. I have a stationary layer. I have a moving layer. This stationary layer is fixed. What is the range? What is the change velocity with respect to the distance between these two layers? This is the moving layer and this is the stationary layer. So what is the rate of change of velocity with respect to the stationary layer and the distance between them? How it is changing? How is the velocity changing with respect to the distance between the stationary layer and the moving layer? That's called the velocity gradient. So what is coefficient of viscosity? Coefficient of viscosity is nothing but eta. Eta. Okay. And what it is? According to the Newton's law of viscosity, basically for streamline flow. Why streamline flow? Because for a streamline flow only, all the layers are parallel to each other. Yes or no? We already studied. Yes. In the streamline flow, all the layers are parallel to each other. Am I correct? Yes or no?
Yes, sir.
So this viscous force is directly proportional to the dv by dx velocity gradient. Velocity gradient. More the velocity gradient, more the force. Less the velocity gradient, more. That means if the rate of change of the velocity with respect to s is more, then the force is also more. Okay, and it is also directly proportional to the area. Also to the area. And what area? What area it is? It is the area of the layer parallel to the direction of the flow. That means if I have a stationary layer and this I have a moving layer. Understood? Understood? What is the layer parallel to this moving layer? This layer. It is the area of that layer. What is that parallel layer to this layer which is moving? That area. So the expression comes to be a eta into dv by dx. Simple. Where eta equal to, this is called viscous force. So fv, okay, not fb. Eta comes to be, eta has to be go that side, no? So it will be fv into divided by a into divided by dv by dx. Eta equal to viscous force divided by area of and dv by dx. This is called the coefficient of viscosity, and obviously it's a constant. It is a constant. Understood? And what would be the unit? Force, viscous force is obviously Newton. This is area is meter square, and this is what? Velocity by distance. Yes or no? Velocity by distance. So what it will be? What? Velocity by distance. Yes or no? Acceleration.
Yes, sir.
Yes or no? Huh?
Yes, sir.
So it will be what? Meter per second square. Is it so? dv by dx, no?
Yes, sir.
Velocity.
Right.
How is the velocity changing with respect to distance? So how will we write? It will be Newton by meter cube per second square. How? Any mistake I did? Meter per second? No. Sorry, I did a mistake. No, hey guys, come on here. You should tell me no if I didn't do a mistake. This is meter square. This is velocity. So velocity will be meter per second, and you again have a distance. Distance is again you have meter. No, distance is what meter. So meter cancel. It will be Newton meter square second per second. So per second will go up. Yes or no? Yes or no?
Yes, sir.
Newton second divided by meter square.
Yes, sir.
This is the SI unit of what? Of eta. Clear? Clear all of you? Swaroop, Rishabh,
Yes, sir.
Swaroop.
Yes, sir.
Good. So now we will study
Yes, sir.
about Stokes law. Now you tell me, I have a liquid. I have a C. Okay. I have a C. There are two types of object going in sea. You have a ship and you have a submarine. Okay. Now tell me, do you think that for a ship and a submarine, will the ship and the submarine be same? That means the floating conditions are same. Or do you think ship is much better? It will sail smoothly and submarine will not float. What is your idea? How do you say? If I say two objects floating, it's going in the water. One is this ship or one is submarine. What is the difference you feel? Just tell me, give an idea. Anyone? Yes.
Sir, can you please repeat the question?
My question is, I have sea. There's an ocean. There are two objects in the sea. One is ship and one is submarine. Obviously, they are moving. So, do you think that the floating condition is it same for both, or can we say no? Ship will move slowly, or submarine will move slowly, or ship will it will be difficult for ship to move, or submarine will move smoothly. So, what do you think? Do you think the first? Let me answer my question. Is a floating condition same for both?
Sir, no, sir. It depends upon the material that you use. The
No,
material which.
material is same. Both are same material. Both are
Sir,
iron.
it depends on the depth of the submarine is.
No. Just tell me, is the floating condition same or not? Yes or no?
No, sir.
No,
No.
sir.
Okay. What else? What else? Just give an idea.
Submarine moves inside the water, inside the sea, right, sir?
Yes. So what will happen in sea? Why inside sea the conditions are difficult? Conditions are more
Yes.
Yes,
more something like friction. Can I say the friction will be more here and less here?
Yes, sir.
Yes, very good. So when I have a ship floating on water, it will only have friction here, only on the bottom part, because it is sailing. Normally your ship will be partly inside. Ship will never be, you will never have a ship completely floating. Remember, if you see the ship, you will see almost 1/3 part maybe will be still inside the water. And unfortunately, in your book, Archimedes principle is not there. Archimedes principle is supposed to be in this chapter, and it is not there. Okay. But for a submarine is going inside the water. When inside the water, the friction is acting throughout the ship. Yes or no? The friction due to the liquid is acting throughout the ship, throughout the submarine. So when it is moving, the viscous drag is more in submarine rather in ship. Yes or no? Yes or no? Yes or no? The submarine
Yes,
has
sir.
to face the viscous drag from all direction, because the water is completely immersed in the water. It is going inside the water. That's why the submarine is built in such a way that it can face. So the amount of viscous drag will be more here than here. Hence, it is like a solid going inside a sphere. So if you see Stokes theorem, we'll come to what is Stokes theorem. So what Stokes theorem says, Stokes theorem will actually find out the value of viscous force, okay, for a for a solid inside a liquid. Write down the viscous force acting on a small sphere falling through a viscous medium. I have a liquid, I have a vessel with water. I am putting a what? A solid. So obviously this will go down. This will go fall down and move below. Yes or no? So this is Stokes theorem says that the viscous force acting, what is the viscous force acting on a small sphere falling through a viscous medium? Obviously, every medium is a viscous medium. Every fluid is a viscous medium. Real life, normally we don't have any fluids which have viscosity as zero. I told you. Only at the critical temperature it is zero. Otherwise, all the liquids have some amount of viscosity. Okay, clear? Hmm?
Yes, sir.
Okay, so what is this viscosity will depend on. So do you think if the sphere is small and the sphere is big, this sphere will have less force than this force? Why? Because this is small sphere and the amount of adhesive force is lesser, so viscous force will be lesser here. Yes or no? So your viscous force will depend on multiple factors. One is the shape of the solid. Second, the viscosity of the liquid. That means various liquid. It will be honey, it will be different. For water, it will be different. Yes? Clear?
Yes,
Radius.
sir.
Radius of the solid, of the sphere. Shape of the solid, obviously, it is a sphere or a, or a square. It can be many things. Okay? And one more is the velocity, of the sphere. How much velocity it is falling? Are you throwing it very hard inside or you're just dropping it? It will depend on all these factors. So we will normally say the shape of the solid and radius of the liquid to be one factor. So you have three factors basically. One is the radius, second is the velocity, and third is the viscosity. Velocity and the viscosity. Viscosity is given by the eta, viscosity, coefficient of viscosity. Is it clear?
Yes, sir.
Is it clear? Swaroop, Dhruva, Rishabh.
Yes, sir.
Yes, sir.
Okay. So we can say that this force is directly proportional to radius, velocity, and what? Eta. So that means if I want to write it as a equal to, I can write this as what? Fv to be what? Some constant times radius into velocity into eta. Yes or no? Yes or no?
Yes,
Guys.
sir.
Hmm?
Yes, sir.
So what is this K?
Yes, sir.
This K experimentally is nothing but 6 pi. This K experimentally 6 pi. So your final expression is nothing but 6 pi R V eta. Is it clear? Is it clear?
Yes, sir.
So how do you know that this is one power? It can be any power. It can be one, second power, third power. Normally how this expression is derived, let me show you. Your Fv is directly proportional, is equal to K into R to the power A, velocity to the power B, and eta to the power C. So, and you know very well what is the through the dimension analysis, we are finding out what is ABC. Let me show you how I did. So if I say FB, FB is nothing but a force. And what is the dimension of the force? M1, L1, T minus 2. Yes or no? Yes or no?
Yes, sir.
And K is constant. So K you can we can ignore it. What is the dimension of radius? Radius is nothing but it's a distance. So I can write as L to the power A. Velocity is nothing but meter per second square. So can I write it as L T minus 2? Yes or no? And eta, we have already seen eta. What is eta? What is eta? What was eta, yaar? Come on. Newton per meter square second. This was the eta, no? So if eta will be m1 L minus 1 T minus 1 to the power C. So if I combine L, this will be LA, and this I can write as LB T minus 2B into MC L minus C T minus C. So I will combine all. So this will be L A plus B into T minus 2B minus C. Yes or no? And this will be MC. That will be equal to what? M1 L1 T minus 2. So can I equate M1 with MC? L A plus B with respect to L1 and this one with respect to this. So what will be M1? M1 will be MC. Hence C is equal to 1. T minus 2. T minus 2 is equal to T minus 2B minus C. So minus 2B minus C is equal to minus 2. And what is C? C is 1. So can I write? Oh, this is not, sorry. Minus 2B minus 1 equal to minus 2. So minus 1 will go that side. Did I make any mistake, guys?
Sir, velocity is meter per second, right?
Yeah, correct. A meter per second. So L minus T minus 2, no? Oh, sorry. Yeah, here I made a mistake. Exactly.
Yes, sir. That's what I was
That's
trying.
why it is not matching, no? That's why it is not matching. Yeah. So minus B, minus 1 equal to minus 2. So what will be B? B will be 1. Clear? Is it clear? Guys,
Yes.
Yes, sir.
very interesting, no? And finally, next one is what? L. L A plus B equal to 1. L A plus B equal to L1. Yes or no?
Yes, sir.
So here also not matching, no? Can you see where I made a mistake? Uh, oh, here no, the guys. L minus C is there, no? So this will be what? L A plus B minus C. I made a mistake. L A, L B, and L minus C. So it will be L A plus B minus C. So L A plus B minus C equal to L1. So A plus B minus C equal to 1. So what is A? B is 1. This is also 1. So what will be A? A obviously will be 1. Then only it will be 1. Yes or no?
Yes, sir.
So A plus B, C is 1. So now we have the formula K R1, velocity 1 and eta 1. And what is this K? This K is nothing but 6 pi. Experimentally. This is nothing. Experimentally the value comes to be 6 pi. So your final expression is FV equal to 6 pi R1. You can write it down, guys. This is not there in any of the book. I have studied and I have found out and I have told you. This is not there in your book. So your final expression is velocity drag, velocity viscous force acting on a what? On a sphere inside a liquid is what? K into R1, velocity 1, eta 1. Is it clear?
Yes, sir.
Yes, sir.
Yes, sir.
So now we will go to the next topic. That is what? That is Stokes terminal velocity. Terminal velocity. Very, very important portion. Exam point of view also. Okay. So terminal velocity, we will see what is terminal velocity. First, let me show you, let me give you a real scenario. Okay. Can we stop it and restart it? Just join the call.
Yes,
Rejoin
sir.
the call.